Look at the word Indian. In how many ways can you permute this? You observe that the word Indian can be arranged in 1, 2, 3, 4, 5, 6 factorial ways. But I is repeated twice and is repeated twice, so divided by 2 factorial times 2 factorial. Pretty straightforward and easy. Application of multinomial theorem basically. Right? Now let me ask a variant of this question. In how many ways can you pick 4 letters from Indian and then consider all possible permutations? For example, you could consider IDNA. This can be permuted in 4 factorial ways. What about IDIA? 4 factorial by 2 factorial. How about IINN? 4 factorial by 2 factorial times 2 factorial. Let me write all possibilities now. IINN 4 factorial by 2 factorial into 2 factorial. IIND 4 factorial by 2 factorial. You see why, right? So I is repeated twice, so 2 factorial in the denominator, that's it. IINA 4 factorial by 2 factorial. INDA 4 factorial. DINN 4 factorial by 2 factorial. AINN 4 factorial by 2 factorial. IDIA in 4 factorial by 2 factorial ways. DANN 4 factorial by 2 factorial ways. This is all possible picking of 4 letters from Indian and trying all possible permutations of these 4 letters. Sum total is the answer that we want. So what is the sum total? Let me write this down. I compute and I observe that it is actually this big sum is going to be simply 1 not 2. Here is the explanation. You can take a look at it. It is 1 not 2. Okay. Now let me look at a different way to answer this question because I need to learn a brand new technique here. Now let me write down I, which is repeated twice. So I will write 1 plus x square by 2 factorial for I. This is I's house. What is a house? Why this? For I, you will get to know soon. Again, see, sometimes it's tough to explain the details of why we do something, but with time you will realize why we are doing it. You need to have a keen sense of observation. For D is repeated only once, so it's 1 plus x. For A, it is 1 plus x. For N, it's going to be 1 plus x square by 2 factorial. So when it is repeated k number of times, you simply write 1 plus x square by 2 factorial plus x cube by 3 factorial plus x to the 4 by 4 factorial up to x to the k by k factorial. Why? You will get to know soon. Okay? And then, so we are done for IDAN. Now, let me multiply all these things and then take a look. I get 1 plus x square by 2 factorial the whole square times 1 plus x into 1 plus x. My question would be, what is the coefficient of x to the 4 here? Let me compute. The coefficient of x to the 4 is going to be simply, how will you get x to the 4 here? By picking an x from the first house. Basically there are 4 houses here. 1 plus x square by 2 factorial, first house. 1 plus x square by 2 factorial, second house. First one is for I, second one is for N. Next would be 1 plus x for D, 1 plus x for A, right? And now, how do I get x to the 4 here? By picking x in all 4. Okay, this corresponds to, the first one is the house of I, the second one is the house of N, the third one is the house of D, the fourth one is the house of A. This corresponds to, if you pick x here, very similar to the partitions generating function that we discussed. This corresponds to 1i because you're picking x from the first house, 1d because you're picking x from the D's house, second house, 1a and 1n. This corresponds to IDAN. And if you look at the coefficient of x to the 4, it will be 1, simply 1. So for IDAN, it will be 1. So if you look at, let's say, if I pick x square by 2 factorial from the first house, x square by 2 factorial from the second house, right? That will correspond to you picking I because you're picking x square by 2 factorial. You see, x square if you pick, it means I is repeated twice. And again you are picking x square from the last one and you're picking 1 and 1 from the D's house and A's house, which means D is not picked, A is not picked, I is picked twice, N is picked twice. So it is IINN. And with that comes divided by 2 factorial into 2 factorial. So coefficient of x to the power of 4 when it's picked this way, corresponding to IINN, will give you x to the 4 by 2 factorial into 2 factorial. Now, if I compute the coefficient of x to the power of 4 overall, I will get this big expression. Look at this. 1 by 2 factorial into 2 factorial plus 1 by 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 2 factorial. Why? Observe, and then plus 1 at the end, which corresponds to IDNA. Why does this happen? This simply corresponds to every possible way in which you can pick x to the 4. As simple as that. The sum total is something which is fractional, you see. Correct? All these fractions add up to some number. But then if you look at the actual answer that we computed carefully, we found the answer to be this: 4 factorial by 2 factorial into 2 factorial plus 4 factorial by 2 factorial, etc., etc., etc. Do you compare these two things? What is missing here is simply 4 factorial. Otherwise, denominators are taken care of. So what we will do is, vroom, we will rewind back and say we do not want the coefficient of x to the power of 4 here. We want the coefficient of x to the 4 divided by 4 factorial. Why? That way it forces a 4 factorial in the numerator. A very, very, very small trick. Think about it. This is the place where you might possibly have a confusion. So you must pause the video and think what I just now said. If you want a 4 factorial in the numerator, you should put a 4 factorial in the denominator of x to the 4. So if you ask this question, what is the coefficient of x to the 4? You will get 1 by 2 factorial into 2 factorial plus 1 by 2 factorial plus 1 by 2 factorial, so on up to 1. That's the answer. But if you ask, what is the coefficient of x to the 4 by 4 factorial? Why did 4 factorial come here? Whatever, I don't care. If you have 4 factorial here, I'll put a 4 factorial in the numerator there. Correct? So it will be 4 factorial whole into the entire thing. Which again, as you can see, look at this step, look at this step, and look at this step. You will get 1, not 2. Precisely what we did. What is the moral of the story? The moral of the story is that if you want to compute in how many possible ways you can pick a k letters from the given n letter word, it is simply find the coefficient of x to the k by k factorial in the expansion of the generating function corresponding to the n letter word. Correct? We did for the word Indian. It is the same for the word engine. Now let's see as a problem, what is it for Mississippi? In how many ways can you pick, let's say, 5 letters from Mississippi and find out the answer? Let us look at this problem and apply our explanation to find a solution.